Welcome, fellow space and science enthusiasts. Welcome to our deep dive into the universe's most powerful energy source, antimatter. It's the stuff of science fiction, often portrayed as a universe-ending weapon or the key to unlocking faster-than-light travel. But what is antimatter really? Today we'll peel back the layers of mystery and explore what antimatter is, why it's so valuable, and how it could revolutionize our future. We'll journey from the subatomic realm, where particles and antiparticles collide in spectacular bursts of energy, to the vast expanse of space, where we'll search for clues about the universe's missing antimatter. Buckle up, because we're about to embark on an exhilarating ride through the cosmos, exploring the mind-blowing potential of antimatter. So what exactly is antimatter? Imagine the universe as a giant cosmic mirror. On one side you have matter, the stuff that makes up you, me, our planet, and everything we can see in the universe. On the other side of the mirror, you have antimatter. Antimatter is like matter's bizarre twin, identical in every way except for one crucial difference: its charge. For every particle of matter there exists an antiparticle with the same mass but an opposite charge. Think of it like this: if an electron is the positive end of a battery, then a positron, its antimatter counterpart, is the negative end. Now when matter and antimatter meet, they don't just shake hands and go their separate ways. Instead they annihilate each other in a dazzling release of pure energy. This isn't your run-of-the-mill chemical explosion, folks. We're talking about the complete conversion of mass into energy, as dictated by Einstein's iconic equation, E=mc2. This equation tells us that a tiny amount of mass can unleash a tremendous amount of energy. And when it comes to matter-antimatter annihilation, we're talking about 100% efficiency. That's right, every single bit of mass is converted into pure energy. To put this into perspective, let's compare it to other energy sources. Chemical reactions like burning wood or exploding dynamite convert less than 1% of their mass into energy. Nuclear fission, the process powering nuclear power plants, converts about 0.1%. Even nuclear fusion, the energy source of stars, only manages to convert a measly 0.7%. Antimatter, on the other hand, reigns supreme with its perfect 100% conversion rate. It's the ultimate energy source, capable of unleashing unimaginable power from the tiniest amounts of material. Antimatter isn't just a scientific curiosity, it holds the key to unlocking incredible technological advancements. Imagine a world where spaceships could travel to distant stars in a human lifetime, powered by the most efficient energy source in the universe. That's the promise of antimatter. With its unparalleled energy density, antimatter could revolutionize space travel. A single gram of antimatter, when annihilated with an equal amount of matter, could release as much energy as the explosion of the atomic bomb that devastated Hiroshima. That's enough to propel a spacecraft to a significant fraction of the speed of light, making interstellar travel a tangible possibility. But antimatter's potential extends far beyond space exploration. It could also provide us with a clean, limitless energy source here on Earth. Imagine a future where power plants are fueled by tiny amounts of antimatter, generating electricity without producing any harmful greenhouse gases or long-lived radioactive waste. Antimatter also has applications in medicine. Positron emission tomography, or PET scans, already use positrons, the antimatter counterpart of electrons, to create detailed images of the human body, helping doctors diagnose and treat diseases. And in the fight against cancer, antimatter could offer a powerful new weapon. Researchers are exploring the use of antiprotons in a technique called anti-proton beam therapy, which could target and destroy cancer cells with incredible precision, minimizing damage to surrounding healthy tissue. The potential applications of antimatter are vast and awe-inspiring. However, harnessing this powerful energy source is not without its challenges. Chapter 3. The biggest mystery: where is all the antimatter? Here's where things get really interesting, even a bit perplexing. According to our current understanding of the Big Bang, the event that birthed our universe, matter and antimatter should have been created in equal amounts. It's like baking a cake and ending up with a whole batch of frosting, but no cake. So, if matter and antimatter were created in equal amounts, where did all the antimatter go? This is one of the biggest unsolved mysteries in modern physics, known as the matter-antimatter asymmetry problem. There are a few leading theories trying to explain this cosmic imbalance. One possibility is that a subtle difference in the laws of physics governing matter and antimatter led to a slight excess of matter over antimatter in the early universe. This tiny imbalance, over billions of years, could have resulted in the matter-dominated universe we observe today. Another theory proposes the existence of antimatter galaxies, entire galaxies made entirely of antimatter. These hypothetical galaxies would be virtually indistinguishable from our own, except for the fact that they're made of anti-stuff. However, detecting such galaxies is a monumental challenge, as the light they emit would be identical to the light from ordinary galaxies. A third possibility is that small amounts of antimatter are trapped in cosmic rays or within regions of space dominated by strong magnetic fields. These pockets of antimatter, while rare, could provide us with a way to study this elusive substance and unlock its secrets. The mystery of the missing antimatter is a tantalizing puzzle that continues to captivate physicists and cosmologists alike. Solving this cosmic riddle could revolutionize our understanding of the universe's origins and evolution. Chapter 4. Can we create and store antimatter? The idea of harnessing antimatter's power is incredibly enticing, but can we actually create and store this elusive substance? The answer, thankfully, is yes, but with some major caveats. Scientists at particle accelerators like CERN's Large Hadron Collider, the world's largest and most powerful particle smasher, have successfully created tiny amounts of antimatter. By smashing protons together at near light speed, these scientific marvels can produce antiprotons and positrons, the antimatter counterparts of protons and electrons. However, creating antimatter is an incredibly energy-intensive process. In fact, producing just 1 gram of antimatter would require an astronomical amount of energy, costing trillions of dollars. That's 1 expensive gram. And then there's the issue of storage. Antimatter has a nasty habit of annihilating with normal matter upon contact, which makes storing it a bit like trying to hold lightning in a bottle. To contain antimatter, scientists use sophisticated devices called penning traps. These traps use strong magnetic and electric fields to suspend antimatter particles in a vacuum, preventing them from touching the container walls and annihilating. While penning traps are effective for storing small amounts of antimatter for short periods, they're not a long-term solution. Researchers are actively exploring new methods for storing larger quantities of antimatter for extended durations, but it remains a significant technological hurdle. Despite the challenges, the dream of harnessing antimatter's power continues to drive scientific innovation. Perhaps one day, we'll develop the technology to produce and store antimatter on a large scale, unlocking its full potential for space travel, energy production, and beyond. Chapter 5. Could antimatter be the key to space travel? Imagine a future where spacecraft, fueled by the most powerful energy source in the universe, could traverse the vast distances between stars, unlocking the secrets of the cosmos. That's the tantalizing possibility offered by antimatter propulsion. Antimatter rockets, unlike their chemical-fueled counterparts, wouldn't require carrying thousands of tons of propellant. A single gram of antimatter, when annihilated with an equal amount of matter, could release enough energy to propel a spacecraft to a significant fraction of the speed of light. This level of efficiency could make interstellar travel, a journey that would take tens of thousands of years with current technology, possible within a human lifetime. Imagine reaching Proxima Centauri, our nearest stellar neighbor, in a matter of years, not millennia. NASA and other space agencies have already begun exploring the theoretical possibilities of antimatter propulsion. While significant technological hurdles remain, the potential benefits of this revolutionary technology are too great to ignore. And who knows, perhaps advanced alien civilizations, if they exist, have already mastered antimatter technology. Maybe those mysterious fast radio bursts and unexplained cosmic phenomena we observe are signs of alien spacecraft, powered by antimatter, zipping across the cosmos. Some scientists even speculate that certain types of gamma-ray bursts, the most powerful explosions in the universe, could be the result of matter-antimatter annihilation events. These bursts, releasing more energy in a few seconds than our sun will emit in its entire lifetime, could be telltale signs of antimatter interactions in the distant universe. The possibility of antimatter-powered space travel, while still in the realm of science fiction, is an incredibly exciting prospect. As we continue to unravel the mysteries of antimatter, who knows what incredible technological advancements await us? The future of antimatter, a universe of possibilities. As we've explored, antimatter holds the potential to be the most powerful energy source in the universe. Its ability to completely convert mass into energy opens up a world of possibilities, from revolutionizing space travel to providing us with a limitless supply of clean energy. If we can solve the challenges of production, storage, and harvesting, antimatter could fuel deep space exploration, allowing us to reach for the stars and unlock the secrets of the cosmos. It could provide limitless clean energy for humanity, ending our reliance on fossil fuels and paving the way for a sustainable future. The real question is, can we unlock antimatter's secrets before another civilization does? The universe is a vast and mysterious place, and it's entirely possible that we're not alone in our quest to understand and harness the power of antimatter. Thanks for watching. Don't forget to like, share, and subscribe for more fascinating insights into the universe.